Thank you everyone for joining us for this webinar on audio over IP protocols, Ultimate Digital Snake, presented by Crain. My name is Laura Lawrence and I'm the Global Marketing Director at Harman. So just a few things before we get started. Everyone on the call is muted to keep down noise levels during the webinar. However, there is a chat function where you can submit your questions and we'll consolidate those and answer them at the end of the presentation. This webinar is being recorded and the link will be made available a few days after this presentation. We do have a number of other webinars taking place over the next few months for audio, lighting, video, and control, and we'd like to encourage you to take a look at those webinars in our Learning Sessions workshop series. You can find that on pro.harman.com, as well as visiting Harman Professional University to see our many on-demand and certification courses that are available to you for free. And now I'd like to introduce you to my colleague, Crain, the presenter for today's webinar. Al has worked in the AV industry for more than 20 years, including roles at SeaWorld and various AV integrators, before becoming a technical trainer at Harman in 2008. With a passion for high-fidelity sound reproductions and course instruction, Al holds CompTIA CTT Plus and AVIXIS BTS certification. And now I'm going to pass the mic over to you, Al.
All right, thank you very much, Laura. So hello, everybody. This is digital audio training, and we're going to be talking about the primary uses of audio protocols in the installed sound installation. So let's go ahead and jump right in. So we're just going to go in alphabetical order. That's the simplest way to do this. We'll kind of save the best for last, which of course we're going to talk about Dante, and that's probably the one we talk most in depth about. But we'll start with the A, which is going to be AVB. We'll discuss the B, which is for BLU Link, which is the Harman proprietary protocol. We'll discuss CobraNet, and then, of course, we'll discuss Dante. And then we'll also talk about some of the AES standards as well, like AES10 and AES67. So first up is AVB, which stands for Audio Video Bridging. So some of the highlights of the differentiators here, I'm not going to read all this out to you, but you guys can read through this. But some of the biggest differentiators between AVB and everybody else is that AVB is the only one we're going to talk about today that also was designed to carry video in addition to audio. So it's over a single protocol where you're carrying audio and video. That's the primary differentiator that AVB brings to the table. Just like everybody else, uses Cat5 cabling. The one interesting thing about AVB is that it does require a specific type of firmware in the switch in order to make that switch compatible with AVB networks. So, and for a number of years, there was only a couple of models of switches that were even available on the market that could do that. Now there's a few more available, including at least a couple of models from Cisco to be able to transmit AVB over that network. So that's definitely one thing that hindered them in the wide-scale adoptance of AVB was just those switches. Another advantage of AVB is ultra-low latency. When you think about the worst-case latency being 2 milliseconds, that's pretty phenomenal. That's one of the lowest latencies we're going to talk about today when we compare all of these various different formats of audio over IP. So AVB was designed to kind of replace the existing technology, which at the time, the primary one was CobraNet. So since CobraNet was capable of 48 kilohertz, 96 kilohertz, and could do 16, 20, or 24-bit depth sampling, we can do the same thing with AVB. So anything you can do with CobraNet, you can also do with AVB. Just like everything we're going to talk about today, if you're using copper, then it's going to be a standard 100 meters per connection. And all of these standards can also be expanded using fiber media converters, where you're basically taking that copper, connect your RJ45 into the converter, it converts it to fiber, and then you convert it back to copper at the other end. So you generally need 2 of these devices, 2 fiber media converters. One that converts from copper to fiber, and then you go however far you need to go, 3,000 feet or 6 miles, whichever the case might be, depending on whether you're doing single mode or multi-mode fiber. And then you convert it back to copper at the other end. So those are generally purchased in pairs. On the right-hand side of this slide here, we kind of see how the network is going to be built. So as you can see here, we have two types of traffic. So we have ABB audio, which is the purple traffic, and then we have control data, which may or may not be HiQNet. Now, of course, in the Harman world, we call our control data HiQNet, but that doesn't have to be obviously Harman. It could be something else. But just this slide for the example here, since this is a Harman class, we're going to talk about the way we do it, which is HiQNet. So the interesting thing here is that you can, although it may not be recommended, you can combine the traffic onto a single switch, which is managing your traffic for audio, video, and control over a single network. It was designed that way, and the ABB was designed for minimal bandwidth, which can help you and allow you to place all three types of traffic onto a single network. Again, the preference would be that you separate out your traffic, especially the HiQNet control traffic, and obviously, you know, with the bandwidth utilization of audio and video over a network, it's going to be substantial. So if you can separate that traffic out, that's definitely going to give you a more robust solution. So basically, at the bottom here, we're talking about, you know, the bandwidth utilization here, and we only use 25% of the bandwidth for ABB, and the rest of it is reserved for everything else. Okay, so that's audio-video bridging. By the way, this is created by the Avenue Alliance, and if you want more information about ABB, this is an open source standard, so an open technology, and this is an IEEE standard. So the other maybe advantage here of ABB would be that there's no licensing fees to pay because it's an open standard. So if you're comparing, you know, apples to apples between the different formats here, realize that there wouldn't be a licensing fee involved as an additional cost that always gets passed along to the customer, the end user, etc. But anyway, if you want more information about ABB and get into the nitty-gritty details, just go to avnu.org, and that's the website for Avenue Alliance, which basically created this, and it has a list of all the partners who support ABB. Next up, of course, we're going alphabetically, so after A comes B, which is BLU Link. So the primary differentiator here with BLU Link is that it is not TCP/IP. It is IEEE Ethernet, but it is not TCP/IP, which means it does not go onto a network. Therefore, there are no switches, no routers, no hubs that are allowed in BLU Link. BLU Link is a direct connection from one Harman device to another. So, of course, the next point is that this is a Harman proprietary technology, which means, again, there are still no licensing fees that you have to pay. Harman developed it for our Harman products, and you can pass BLU Link around, whether that's VSS products from Harman, AKG microphone mixers from Harman, Crain amplifiers from Harman. All those Harman products allow for BLU Link. Soundcraft and Studer mixing consoles also. You can purchase the BLU Link card to transmit audio across Cat5 cable. It happens to be Cat5 cable, but that's for the most part where the similarity ends between BLU Link and everybody else. It's just a point-to-point connection. So generally what you can do is you just wire your BLU Link as a daisy chain. So maybe you have a rack full of Harman equipment and you just want to get your audio from device to device through the signal chain. That can be done in daisy chain configuration. If you want the added redundancy here, you can actually link the last device in the chain back to the first device. So that would give you basically redundancy here. So if there's a failure anywhere along the signal chain in what would have been your previous daisy chain configuration, there's an automatic failover here because audio is already traveling across the other direction from other devices. So this is an automatic self-healing network, if you will. But just keep in mind here, as you see, the blue lines are BLU Link, which connect all the Harman devices together, and the yellow lines are your network. So this again would be HiQNet for us in the Harman world. But all your network traffic is going to travel from the network switch to the HiQNet connector, the RJ45 Ethernet connector on the back of your Harman device. Another advantage here of BLU Link is the high channel count. So with other implementations, and I think we saw this on the previous page here, with the BSS Harman implementations, you notice here that we only allocate 64 channels in each direction. Again, this is the limitation from Harman. So this the chipset that we use allows for 64 in, 64 out in BSS devices. However, when you move to BLU Link, you expand that to 256 channels at 48 kilohertz. And basically all the Harman equipment supports 48 kilohertz. Some Harman equipment supports 96 kilohertz. And just be aware, of course, that if you double your sampling frequency, you cut the channel count in half, down to 128. So like ABB, we also have ultra-low latency. And the latency here is measured a little bit differently here. We actually measure latency by hop count. So for the first hop between two Harman devices, it's 11 samples. And then each additional hop after the first hop, it's only 4 samples. So you're basically talking about a few microseconds here of latency between each hop. And then, of course, the maximum hop count, which you see down here, towards the bottom of my screen, this indicates that there's a maximum of 60 Harman devices allowed per ring. Another advantage of BLU Link is you can actually create multiple rings, or what are called multiple buses of BLU Link. So if you have, maybe different racks in a facility, and you want to wire all those racks together with the gear in each rack, that can all be done on a BLU Link, and then you can use some other format to transmit the audio from rack to rack. Then that could be anything. It could be BLU Link, it could be CobraNet, it could be Dante, it could be AAV. But just keep in mind, in a rack full of gear, you might have 10 pieces of equipment. So you're talking about, still less than 1 millisecond of latency total for 10 hops. The bit depth is fixed in all of BLU Link, and it's fixed to 24-bit depth, and that's not adjustable. We are translating the audio into digital internally, and since we're in control of that, we fix it at 24-bit depth. All the ports across everything that has a BLU Link in input and output on it, those ports are all auto switching. That means we can use crossover cables or fixed cables. It doesn't matter. It doesn't care. It figures it out and it just works. So that's probably another advantage of BLU Link, is the simplicity here. Again, there are numerous advantages of not being on a network. Obviously, there's no hardware to buy, right? There's no switches, no routers, no hubs to buy. So from a cost standpoint, that could be a huge advantage. Another advantage is there are no IT personnel to pay to manage the network because there is no network. So, that can be a huge cost. Oftentimes is, having to pay for a drop, in some cases for every drop onto the corporate network or the campus network or whatever that might be. Oftentimes there's a fee to pay just for the drop, and then there's also a monthly maintenance fee for that drop. That would not be any kind of a concern whatsoever with BLU Link because it doesn't touch the network. The other, and probably one of the big benefits that I see with BLU Link is reliability. And I'm going to iterate this pretty strongly, but BLU Link is by far the most reliable of all the platforms we're going to discuss today. Of all these protocols, BLU Link is without a question the most reliable because we are not depending upon any network equipment. There's no switch to get, maybe your IT manager accidentally loaded the wrong VLAN into a switch somewhere. Well, if that happens across anybody else, whether it's ABB or CobraNet or Dante, you're going to lose your audio. But here with BLU Link, it would not affect your audio because it doesn't touch that network. You know, power supplies go bad from time to time. Lightning strikes can take out a power supply or take out a piece of network gear. So the reliability is by far the highest with BLU Link. And that's one of the things I appreciate the most about it. I did already discuss the two different topologies between daisy chain and ring. And again, just like everything else, it's 100 meters from device to device. And again, VSS is compatible with 5-meter converters. And we have the BLU MC1, or if you are interested in doing this over fiber, you can get with me. I think Laura's going to include my email contact information in the presentation. So after this session, if you're interested in doing this over fiber, or if you have any questions about doing it over fiber, just feel free to email me. I'll be happy to get you that model number of the recommended 5-meter converter that we use. Lastly, if you have other, more detailed questions about, BLU Link, there's a technical write-up on it on the website. It's bssaudio.com/en and then /network-audio. Again, just the big takeaway here for BLU Link is that it does not touch any piece of network equipment. It's just a direct wire. So on every BLU Link device, every Harman device, there's a BLU Link in and a BLU Link out. And you just take the out of the first device and wire that to the in of the second. And then it's the same thing for your entire daisy chain. Out to in, out to in, out to in, all the way around, whether that's a ring or daisy chain. And then if you're doing a ring, you take the last out. In this case, it's the CDI BL amplifier. So the BLU Link out from that amplifier goes into the BLU Link in of the BLU USB. Next up is CobraNet. Now, it may not be a relevant discussion for you in your use case, but because of the number of deployments and the length of time that CobraNet has been around, I think it does belong in this discussion because it was really the game in town back in the early 2000s. I mean, this is, if you wanted to send 32 channels of audio over Cat5, you didn't have very many choices of how that was done back at that time. So this was the way it was done for many years. So there are obviously a lot of existing systems that are already installed and using CobraNet. So obviously Harman still supports CobraNet. And then in the case of BSS Audio, that's the BLU 800, which is your bridge from CobraNet back to BLU Link, or audio ins and outs, however you want to do that. So because it was first, obviously, there are some limitations here. The biggest limitation that I think there is of CobraNet is the low channel count. With everything else, you can do 64 channels. In the case of BLU Link, 256. But here with CobraNet, we only do 32 channels in and 32 channels out. And another limitation of CobraNet is that these 32 channels are grouped into 8 channels called a bundle. And then once you've utilized that bundle, maybe you only need 2 channels for a stereo audio pair on that bundle. Well, you may not be able to use that same bundle for your other audio because of the way the audio is routed across CobraNet. So that can be a limitation as well. But the low channel count is definitely one of the limitations that you're going to find there. I don't see, honestly, in my field, I don't see a lot of new installs being done with CobraNet. I tend to see more existing systems that are being added to or upgraded where they want to maintain their CobraNet system and just add to that existing system. That is still being done. So that's kind of why we mention it here in this presentation. Latency Again, this is, going back, almost 20 years now. So the latency is a little higher. It's 5 1/3 milliseconds. Although, depending on your network configuration and the number of hops, it is possible to bring that down to as low as 1.33 or 1 1/3 milliseconds. Like I mentioned before, when talking about ADB, audio over IP allows for either 48 or 96 kilohertz sampling. And of course, the bit depth can be anything from 16, 20, or 20. All the other rules apply about copper and fiber. On the right-hand side here, this looks very similar to your ADB, where you might have two separate networks, one for your audio traffic and then one for your control traffic. Or you can, because of the minimal bandwidth, and you're only talking about 32 channels of digital audio here, so it is minimal bandwidth, and you can more easily get away with combining the traffic onto a single network. But again, for the most robust system, I still encourage everyone that if you can, separate the traffic out so that a high QNet traffic is its own network. It's the data network. It's not transmitting, 32 channels of audio in each direction. But you can, for a small system where you only have maybe 8 or 16 channels of audio, this probably wouldn't be a problem at all, and you probably never even see it. For more information on CobraNet, it's just cobranet.info is the website for them. By the way, I didn't think I mentioned this, but CobraNet is also a licensed technology from Peak Audio. So again, there is going to be a licensing fee that has to be paid up to Peak Audio, and that's in every device that uses CobraNet. That still applies. Okay, next up we have probably what you've all been waiting for, which is Dante. So Dante, again, is a licensed technology, and typically the way it's done with Dante, at least for third-party hardware manufacturers like Harman, is that we buy a chipset. A given chipset determines the channel count for that Dante implementation. So across most Harman devices, we use what's known as the Brooklyn 2 chipset. Brooklyn 2 allows for 64 channels by 64 channels, and that's fixed at 48 kilohertz. Oops, I guess this got cut off. This is supposed to say Brooklyn 2. An error in the slide. We use anything Cat 5 or better. Obviously, you need a network switch if there are more than two Dante devices in the network, which most of the time there's going to be way more than 2. The interesting thing about Dante, there's lots of those, but one of them is that you can actually set the latency to what you want it to be. Now, obviously, this is going to be, especially if you have maybe Dante, you're streaming from a PC or to a PC where you're using a DAW, that latency, if you're going to go for ultra low latency, is going to affect your DS or your CPU utilization of that computer. So just keep that in mind, that there's always a trade-off. And everything there's a trade-off, and the trade-off here is CPU usage versus latency. Again, it supports 4896 kilohertz sampling, and it's fixed at 24-bit. Just like everything else, it's 100 meters. Also compatible with fiber. And for those of you who aren't already aware of this, Dante has largely taken over the industry, at least the installed sound solutions for distribution of audio over IP. And people ask me why I think that is the case, and I honestly believe it's their software. Dante is created by Automate, and Automate makes phenomenal software. I mean, there's just no way to deny how good these software engineers are. So let's go through the Dante software here really quickly and kind of give you some insight as to what this software is and what the value of it is and why it has really brought Dante to the forefront. So the first software we're going to discuss is Dante Controller. and I happen to have Dante controller here, and I've got some devices you see on my screen. Hopefully that's coming across my screen now. So I have 4 different devices on my network that support Dante. I have my own laptop here, which is running another software program from Audinate, which is called Dante Virtual Sound Card. So this item here labeled Al's Laptop, DVS, that's the Dante Virtual Sound Card in my laptop. And I can do anything from stereo 2-channel all the way up to 64-channel by 64-channel on this Dante Virtual Sound Card. Next up, I have an Amx Dvx Forte, and of course the new Forte DVXs all support Dante, and they support 8 channels in, 8 channels out of Dante. So if I expand this, you'll see here that the way they do it is they group it in left-right pairs, and I have 4 pairs of left-right audio, which is a total of 8 channels. So I have receive 0 left and right, all the way up to receive 3 left and right. These 4 stereo pairs. And then if I want to route that, maybe I want to route it from my laptop to the DVX, I can just expand this, and then if I want to create a cross point here for my laptop, I can, if I just have stereo audio coming from my laptop right now. And that's it. That's all there is to doing a routing. So the simplicity of this, the ease of use, there is almost no learning curve. If you've ever used a matrix router before in your life, then you can route Dante audio traffic. You can route Dante depending upon which software you're using and which hardware you're using, either 512 channels in this router or up to 1024 channels. So over 1,000 channels of audio can be routed here using Dante controller. So that's a pretty massive matrix. You're talking about 1,000 channels of audio. But the beautiful thing here about Dante controller, besides the fact that it's free software, is how powerful it is. And every Dante device is automatically discovered in Dante controller. So again, another advantage of Dante is that they are completely brand agnostic. It doesn't matter if your device is made by Lenovo. In my case, I've got a Lenovo laptop here, or it's made by Crain, or it's made by BSS, or it's made by Amx, or it's made by Tascam, and it's a Tascam 32-channel Dante recorder. It doesn't matter who's made it. If that device is Dante, it's going to show up here automatically in Dante control. And again, this routing is as simple as picking a cross point, and I can route as many channels as I want in or out. So the labeling here might be new to you, but basically source devices are called transmitters, and then destination devices are called receivers. And that's how audio is routed in Dante. And notice here, my devices are showing up as transmitters and receivers. Some devices, maybe a recorder, for example, a Dante recorder, might only show up as a receiver because it can only receive Dante traffic. So, but just know here that my particular devices can all be used as either a source device or a receiving device. And I can do any routing that I want. So you might be asking, why is a Crain amplifier showing up here as a transmitter? How would you ever transmit audio from a Crain amplifier onto the Dante network? Well, one feature of the Crain DCIs and CDI amplifiers is that the analog inputs actually function as an on-ramp to Dante. So I have analog audio coming in on my 3-pin Phoenix connectors, and then the analog audio, there's a configuration inside the amplifier that I can assign those analog channels to be converted to digital and then assign to any of my channels that I want onto the Dante network. So that actually allows me to route Dante traffic coming in as analog audio into the amplifier. and then I can send that to my laptop if I want to, whatever that might be. So I can just do this. This is a 4-channel amp, so I can do 4 channels here coming in, and then that's sending 4 channels into my laptop, and I can just use my DAW to record those 4 channels, or bring in those 4 channels to do whatever I want to in my DAW. So lots of power there. And this is the Dante virtual sound card really is the secret weapon here of how this is done. So just keep that in mind as well. These offerings from Audinate can work together. So I'm just going to rate my DAW real quickly here. So as you see here, I have a 4-track DAW playing. This is actually Adobe Audition, and my tracks are tied to a Dante channel, so I can change these to whatever I want across my Dante network if I want. So that's the beautiful thing about working with a DAW. So that's one piece of software. That's called Dante Controller. Again, this is a free download from Audinate's website. You do need devices on the network to be able to test this and actually see things appear here and to do routing. So for testing purposes, the only way to really test this is to have actual Dante hardware on your network. But the beautiful thing is it does automatically appear there. It just pops up once that device boots up, and then you launch Dante Controller. Just as a side note here, if you're using Dante Controller on a laptop and your IT department has really restricted some of the ports that are locked down, you need to have those ports open because there's a number of ports that Dante uses to recognize these devices. So keep that in mind. One more thing I want to point out here from the software, the very top of the screen up here, you can see it says Grandmaster Clock, and my current clock is my BLU 806. So this is the DSS Audio DSP, and that's acting as the master clock. I can manually assign my preferred master clock, or I can allow Dante Controller to automatically choose a clock for me. So let's talk about clocking. Really quickly over here on the right-hand side of the screen before we get into clocking, same as you've seen before. However, because of the higher channel count here, it is really strongly encouraged that even though you can place all the traffic across a single network, it's really encouraged that you separate out the high QNet control data from the audio. Keep in mind, this is just 64 channels per, in our case here, per piece of Harman hardware. Whether that's Soundcraft or Studer or BSS or Crown, 64 channels is the maximum. So other devices have different channel counts. But that doesn't mean that I can't still route 512 channels by 512 channels over here in Dante Controller. It's just 64 channels per piece of Harman hardware. So if I've got, 10 BLU 806s, well, that would give me 640 channels that I can route. So this is a really powerful router. And with that many channels of traffic coming across your network, 640 channels, that's a lot of bandwidth. So it's really strongly encouraged that you separate out that control data traffic from the audio traffic on Dante. Okay, let's talk about clocking. Master clock. So Dante has a built-in system for what's called clock election, where it chooses your master clock. Now, what I've done in my Dante controller is I have actively set my own preferred master, and I made the BLU 806 the primary master. And what I could even do is I could sync my BLU 806 to a Big Ben master clock, and then I'm technically syncing off of the Big Ben master clock because I have clock in and out on my BLU 806. So it says here that, is there more than one? Well, no, I will not do that. And then that device, you just literally check a box and you make that the master, the preferred master, and then Dante assigns that as your master clock. So this is in the background. If you don't check any boxes, Dante automatically goes out to the network, looks at all your devices, and then it automatically chooses a clock for you, the best master clock. And it's going to sync to that master clock from then on until that device falls offline or until you set a preferred master. So this is kind of the auto magic behind clock election with Dante. I don't expect you guys to memorize this. I'm just going to throw it out here for you guys to kind of see, you know, a little bit behind the curtain of how this works. All right. Oh, you know what? I'm sorry. I skipped over talking about the other software solutions. So again, I did mention Dante Virtual Sound Card. I have this installed on my computer. This is not free, but it's not very expensive. It's probably cheaper than buying an actual, you know, even a 2-channel hardware sound card for your computer. I'd say on the order of magnitude of about, you know, $50 US, somewhere around there. Same thing for Dante Via. Dante Via is a little different than Dante Virtual Sound Card. It allows me to take any app on my computer and make that application its own source that shows up in Dante Controller. So maybe if I install Dante Via, I can assign title music to Dante Via. I can assign Amazon Prime music to Dante Via. I can assign my Apple iTunes to Via, and then those all show up as separate sources in Dante Controller, and I can then route to anywhere else on my entire Dante network. And again, those natively show up in Dante Controller. And again, I think Via is around 50 bucks. That's US dollars. Next up is the Dante Domain Manager. This is the newest product offering from Audinate. This is really managing your entire audio network for IT professionals. If you want to be able to do control, monitoring, routing, and you are an IT professional or there's an IT professional on staff that can set up all this, packet monitoring basically, you can do that with Dante Domain Manager. There's various different license levels available. I think there's silver, gold, and platinum. And I think the basic model, the basic version, I guess, is about $1,000 US. Give you kind of a perspective there on the price. So it's a considerable jump up, but the power that it gives you, even to do more advanced things with routing, system status, notifications, all of that is built in Dante Domain Manager. So it's very powerful software. For large networks, it's probably a good idea to consider Dante Domain Manager. If you're only routing, 8 channels or 12 channels of audio around, you may not need Dante Domain Manager. It's also referred to as DDM a lot. So if you hear someone talking about, Audinate DDM, that's what they're talking about is Dante Domain Manager. Lastly here, Audinate originally said they were never going to make hardware, and then of course they made some hardware. But nobody really complained too much about it because their hardware is that solid, it's inexpensive, and it kind of meets a niche need in the marketplace. Let me just bring that up real quick here. So they're called audio adapters, and they make several of them. So there's a USB version, that's basically USB from your computer onto the Dante network. There's an analog version with 2 XLRs, so you get stereo audio over XLR balanced to Dante. And then there's the other direction, it's Dante to 2 balanced XLRs. So you can do, take it, maybe you have whatever, a 20-year-old CD player that you just love, but you wish you could get onto your Dante network. You could literally, if it's an XLR, output on that CD player, maybe it's a rack mount, pro level CD player, take the analog audio out to that CD player, plug those analog outs into your audio adapter, And now that traffic is now on your network. So you now have your CD basically streaming the audio over Dante onto your network. So that's the advantages of those of the AVIO adapters. So this is kind of a screenshot of Dante Domain Manager here. And it's just, explaining to you literally the level of detail that you have in monitoring that network. This you can't do to this level of granularity in Dante Controller. So for large networks, it's a good idea. It really is. And of course, it's implemented very well. Like all software there is from Automate, it's implemented very well. So at the top of the screen there, you actually see a picture of the Brooklyn 2 chipset. So this is what we use here at Harman inside of most of our hardware. Not that everything has a Brooklyn 2 chipset in it, but most things do, and all the BSS stuff has Brooklyn 2 in it. But there are different adapters, like I mentioned before with the DVX. It has the 8-channel chipset in it. Okay. After Dante, we talk about AES67. So I think to start with the big picture here, it's important to realize what 67 is, because it's not technically just another routing protocol like Dante or CobraNet or ABB. What it really is at its core is an interoperability standard. So it's a set of rules that basically everyone else adheres to in order to pass traffic from different types of devices. So let me just expand the slide here a little bit, explain how this works. So there are in the world multiple types of PCM audio, pulse code modulated audio. Dante uses PCM, Livewire uses PCM, so does Ravina, QLAN, and Wheatnet. They all use PCM at the core. But the problem was that there were certain different ways of packetizing the data across the network. So you couldn't just send Dante traffic to a Livewire device. And you couldn't just send Livewire to Ravina, and so on and so on. So there was a need in our industry for a bridging compliance, basically. And that's what 67 is. That's the question that it answers, is how do we create a bridging compliance between these very different types of packetized data. And so the answer was AES67. So as long as the traffic that you want to send to Livewire from your Dante device is following the rules of AES67, then the Livewire device can receive that traffic as AES67 traffic. That's really the point here, is it's not just another protocol to send and receive and route traffic across the network. It's really an interoperability standard. So that standard, it's just pages of technical documentation, but basically the bottom line is latency must be less than 10 milliseconds. It supports 48 kilohertz sampling. It also supports 96, that's not on the slide here, but AES67 can also support 96 kilohertz sampling. Obviously, they do recommend a gigabit network for that. You get high channel count, which is 512 channels at 48 kilohertz. So that's 512 channels, 48 kilohertz sampling, but that's only if you have a gigabit network, which, in today's world, most networks are gigabit anyway. So as far as networking tools go, we have Wireshark filter, and you can filter for SAP traffic. And then, of course, we have the Ravina, the RAV to SAP application, which can let you see this traffic and see the networking behind that. If you want more information about AES67, You can visit the Media Networking Alliance, and of which Harman, of course, is a member. So we are a member of this alliance, and actually so is Automate. So those are all, everyone you see on the right-hand side, those manufacturers are all a member of the Media Networking Alliance, which is a group of people who have agreed to adhere to the rules of 67. I'm going to go through this really quickly here. I tend to do a longer presentation on why we need it, but I'm going to just really quickly here briefly cover this since we're running out of time. We're almost at the top of the hour. So on typical stadium solution, you have, cameras and microphones out on the field. So maybe your microphone mixer is a WheatNet I/O blade, and that WheatNet traffic is traveling up to the broadcast booth, so the broadcast announcers can hear what's going on in the field. But the problem is inside of the broadcast booth, all the gear is Dante because it's installed by an integrator. And then out in your on-air broadcast truck, they're using all Robina because it's broadcast equipment, and broadcast tends to use Robina for a lot of things. So there was a question of, well, how do we get the audio from WheatNet to Dante to Robina? And in the past, there was different ways of doing it. You can convert back and forth to analog, but that can cause a lot of noise. So the solution was to use AES10, and that would connect them all together. AES10 is also known as MADI, and you've probably heard that term before. So MADI is the term we use to talk about AES10. But MADI has its limitations as well. The advantage with 67 is I can now do all that over networking. I don't have to keep converting it from WheatNet to MADI, and then MADI to Dante, and then Dante to MADI, and then MADI back to Robina. Do all that conversion. I can just send the audio AES67 compliant across the entire system. Here's an example of what MADI looks like. So notice this is actually an interface that converts Dante traffic to MADI. So there's lots of options here. MADI's been around a very long time. It's very popular. But again, there's limitations there that you just don't have to worry about with 67. I will quickly mention here that if you need to utilize your existing infrastructure across a large stadium, for example, you can take all the gear in a rack and just BLU Link all that gear together. If it's all Harman equipment, you just tie BLU Link into out across all the devices in each rack, and then the racks or the IDF closets or whatever they might be are tied together using anything else, whether that be ABB, CobraNet, or Dante. Those cannot, generally it's Dante, to be honest. Most of the time people use Dante on the existing infrastructure to pass the audio from IDF to IDF. And then in each IDF, there's a converter that converts the Dante traffic to BLU Link, and then it's just BLU Link into out. And this is the summary of how to get a hold of me if you need to. This has got my email address, phone number on here. If you want more training, you can go to training.harmanpro.com, and there's just literally thousands of hours of presentations on that website. So feel free to utilize that resource as well. And we do have a tech support line that you can call, whether that's parts and repair or our primary tech support for any brand, whether it's BSS, Crown, Amx, etc. Those are all supported there by our all brand support number you see on the screen. And Laura, that's about it for my presentation.
Okay, great. We do have some questions. The first one is asking, if I need to extend above 100-meter distance, what should I do?
Well, remember, this is 100 meters per hop, right? So if you're just going into a device and then out to the next device, it regenerates, and you can go another 100 meters from that device. So if I've got, let's just use BSS as an example here. If I've got a BLU 806 at one point, and I've got, maybe 100 meters away, I have another BLU 806, I can then go another 100 meters from there. Well, that's one way you can do it. The other way, of course, is just to convert to fiber. And with fiber, with single mode fiber, you can actually go 10 kilometers, which is 6.2 miles. So that's two easy ways to expand beyond the 100 meters.
Okay, the next question is asking, is BLU Link a layer 1 solution?
Technically, yes, it is, because it is IEEE Ethernet. So it is true Ethernet. It's just not TCP/IP layer.
All right, next question. How does BLU Link compare to MADI?
Well, generally speaking, MADI has a smaller channel count, right? We have like AES-EBU, which is digital audio over copper. And then we also have BLU Link, which is digital audio over copper. But generally speaking, 256 channels is a pretty high channel count. You aren't going to find that, at least to my knowledge, on MADI. MADI's been around for a long time, so back when that technology was, at its prime, at its peak, there was definitely fewer channels, and it was almost like, shielded twisted pair cable, right? 22-2 shielded twisted pair was the cable you used for MADI. Now I know nowadays they've moved up to doing it over Cat5, but channel count's not there.
All right, the next question is asking, will the channel count for ABB be opened up to 480 in the future? I'm
not aware of what is being done with ABB, to be honest. As far as what their development is, or future products or future technology, I don't know what's being done there for their development.
Okay, the next question is asking, is it possible to use BLU Link to interface different protocols?
Yes, so the interesting thing about, especially on the BSS side, is that each BSS processor or expander that takes in BLU Link is also a bridge to another format of audio. So for example, the BLU 806 is a Dante bridge to BLU Link. So I can use that as my bridge between Dante and BLU Link. If I wanted to bridge ABB to BLU Link, then I'd buy the BLU 805, because that's a bridge. So all the channels that are available, 64 channels, to 64 channels of BLU Link. And then of course, if I want to do CobraNet, I can do 32 channels of CobraNet on the 32 channels of BLU Link using the BLU 800 series.
All right, next question is asking, how do you separate Dante control data from audio on BSS devices and Crown amps using Dante?
So luckily, and this is true not just across Harman, but across really all manufacturers, is there's usually a separate network connection or control. It's just labeled Ethernet probably on most of them. Even some Harman devices just says Ethernet. On some Harman devices it says HiQNet, but that's your control traffic. And then it also has two separate RJ45s, which are labeled Dante primary and Dante secondary. And you could literally, if you had two separate hardware networks, you could literally have a hardware network for your Dante primary, a secondary hardware network for your Dante secondary, and then a third hardware network for HiQNet. They don't have to be separate hardware networks. You could actually just VLAN these out as well, and VLANing works just as, in some cases as well as separate hardware.
All right, the next question is asking, does IDX support Dante?
I'm not that familiar with our IDX product, so I really can't answer that.
All right, the next question is asking, can I use HiQNet to link my PC for recording multi-track?
So HiQNet is just the control data. It's not audio. If they meant BLU Link, then yes, there's what's called a BLU USB interface. And then you take the USB audio out of your computer that converts the USB audio to BLU Link, and then that's how you get onto your Harman equipment. And that could be anything. It could be DSS, it could be Crown, it could be a Soundcraft mixing console if you want it to be.
All right, next question is asking, if I'm using DSS 101 having BLU Link with DCI amp, can I send the audio over to Dante to another network?
No. So the BLU 100 series are not a bridge to something else. That's really the biggest difference, because there's such a price difference, is they don't act as a bridge. So the BLU 100 series devices only support BLU Link. They don't support Dante or ABB or CobraNet. And the Crown amplifiers only support one type of digital audio. It might support Dante, it might support ABB, it might support BLU Link, but it's not going to support any two of them. I hope that answers that question. You can always ask for clarification if that's to clarify your answer.
All right, the next question is asking, what kind of cabling do BLU Link devices require, 568A or 568B?
It doesn't matter.
Okay. Next question, when making routes to an AES67 device, does the device show up in Dante controller like other Dante devices?
I'm sorry, can you repeat the question?
Sure. When making routes to an AES67 device, does the device show up in Dante controller like other Dante devices?
Oh, that's a great question. I didn't mention that before. That's actually a very good question. So what happens here in Dante controller is you see all these devices showing up in black. If it shows up with black text, that means it is a Dante device. If the traffic is recognized as AES67 traffic, it'll actually show up in blue text. So that's how you know. But yes, you can route between 67 and Dante here in the router. It doesn't affect the routing, it just shows up in blue. So you can differentiate between your 67 traffic and your Dante traffic.
All right, the next question is asking if ABB is free licensing protocol.
Yes, it is. It's basically open source. Yes.
Okay, next question is asking, how do you get audio from Harman devices to PC for recording?
Again, it depends. You could do it over Dante. So the way I do it here in my house is I have a BLU 806 in my rack, and then all my analog audio comes into my BLU 806. That gets converted to Dante, and then I send Dante across my house network into my laptop, and then I receive that audio using the Dante virtual sound card. And I can pull that up, actually. I actually have it running right now. So this is the DVS, and if I stop the DVS, I can change the channel count to anything up to 64 by 64. That's how you bring audio in via Dante. If you need fewer channels, like 8 channels of audio, then you can actually just use the BLU USB and do BLU Link from any Harman device that supports BLU Link right into your BLU USB, and then that converts the audio from BLU Link to USB, and that just plugs USB right into your computer, and that gives you up to 8 by 8 channels.
Okay, the next question is asking, what is the audio format from the USB port of BSS BLU USB? Is it data, isochronous transfers, or wave?
You know what? I'm not sure. I have to look into that. That's a really good question. Let me write that down and I'll look into that. And if that person who asked the question wants to email me, I'm going to look into this and find the answer and get back to you. So just shoot me an email and I'll be happy to get back to you on that.
Okay, we have another question. If DCI amps can be used for Dante transmission, which application can we use it in?
One more time, please.
If DCI amps can be used for Dante transmission, which application can we use it in?
Well, it's going to show up in Dante controller. So just like I have here, if you're using the analog inputs as an on-ramp to Dante, then you just go into here, and that's where these show up. So because the Dante amplifiers support up to 8 analog inputs. They support 8 channels of on-ramping to Dante.
Okay, it looks like that was the last question to come in. So Al's contact information is up on the screen. If anybody wants to follow up with additional questions, I'm sure he'd be happy to take those questions from you. And if you're interested in any more of our learning sessions workshops, you can find those on pro.harman.com. There's a full calendar of all of the upcoming classes. Al, thank you so much for the presentation today, and everyone, thank you for attending. We really appreciate your time. Have a great day.
Thank you, everybody.